The question is, what is a proportion? A proportion is a statement that two ratios are equal. Yes, 5-2. A proportion is a statement that two ratios are equal. So when we ask you, is 2/3 proportional to 5, we'll make it 10/15. Is 2/3 proportional? Is it equal? That's what that means. To 10/15. Two ways to answer that question. One is you actually simplify 10/15. If it does simplify to 2/3, then they are proportional. That's one way of doing it. Simplify this one by 5. This is what? 2 by 5. This is 3. Are they equal? Yes. So 2/3 and 10/15 are proportional. They are equal. But what about if you can't simplify a problem? 2/3 and 7/15. Are they proportional? Are they proportional? Well, I can't simplify. So what's the other option? Is actually cross multiply. Multiply 2 times 15, which is what? 30. Multiply 3 times 7, which is what? 21. Are they equal? No. This is not proportional. Meaning not equal.
So proportion means not equal?
Proportional means equal. So these are proportional, they are equal. These two ratios are not proportional because they're not equal. (15/9) and 8/5, are they proportional? So question mark, I'm asking, are they? If I cross multiply, what's 15 times 5? Is that 75? What's 9 times 8? 72. Are they equal? No. Are they proportional? No. Not proportional.
So they gotta equal the same rule?
Have to be. Not proportional. Well, what's going to happen next is we're going to give you a statement or proportions to solve it. So this is called solving proportional or proportions. (840 to 4 is equal what to 10? 840 to 4 is equal what to 10? So I'm looking for a value for x that will make this ratio equals to that ratio. What should I put here? 1 over 10 will not. Notice first, this number is bigger than this. The top is bigger than this. For these guys to be equal, the top of this must be bigger than this. So 1 is out. But we're going to use the same logic, cross multiply. 4 times x is what? 4x. 840 times 10, 8400. And to solve for x, what do we do? Yep, divide by, what was it? 4. X will be what? 2100. So if you put 2100 in here on top of 10, this ratio will equal to that ratio. You can test it. You can go, let's check the answer. Let's check the solution to see if we did it right. I'm saying 84 over 4 is the same as 2100 over 10. Well, if I am right, and if I cross multiply, what's 840 times 10? 840 times 10? 8400. What is 4 times 2100? 8400. Is this side equal to that? Yes. Sometimes actually you can look at it and guess it without having to do extra math. Meaning what? Like this example. Now I don't have to be really fancy with this, but if you look at the bottoms, this denominator is how many times bigger than this? 3 times what will make it 15? 5. All you got to do is multiply the top by 5. What's 2 times 5? 10. So this, I can look at it without doing fancy math. I go, oh, that has to be a 10. Because this number is 5 times bigger than this. That means I got to multiply this by 5 to make it 15. I need to multiply the 2 by 5 to make it the 10. Or I can cross multiply 2 times 5, which is what? 30. 3 times x, which is what? 3x. To solve for x, you divide by 3. X equals what? 10. X over 6 equals 12 over 9. Solve it. Cross multiply. X times 9, which is what? 9x. 6 times 12. 6 times 10 is 60. 6 times 2 is 12. That's a 72. To solve for x, we divide by what? By 9. X equals 8.
So you only solve for x when they ask you to?
That's it. Solve proportion. Solve for the unknown. You're going to have one unknown there. Could be x, could be y, could be z, anything you want to call it. I'll throw some fractions. You know I'm going to keep bringing fractions. 1/2 to 12 equals y to 96. Cross multiply. So what's 1/2 times the 96? 1 times 96 is what? 96. 1 times 2, which is 2. When you're multiplying, there is no LCD there. What's 96 divided by 2? Is that a 48? So it's a 48. So what's 1/2 times 96? 48. equals 12 times y. 12y. To solve for y, what do we do? Divide by 12. Y equals 4. I'll make an uglier one. 2/3 to 5/4 is the same as 5/7 to x. Solve for x. Cross multiply. 2/3 times x. 2/3 x equals. Let's multiply these two. Let me go to the side, multiply them. What's 5/4 times 5/7? When you multiply, it's the top times the top. 5 times 5 is what? 25. 4 times 7, which is what? 28. Now, we talked about solving an equation like this last time. We said the quickest way for them is what? That was chapter 4.
You said what?
The quickest way to solve an equation like this is what?
Dividing it.
Well, you can divide, but there's a quicker way. You multiply both sides by the reciprocal. Remember that? Flip that one. Because when you divide by 2/3, divide by 2/3. That means you're going to multiply by the reciprocal. You flip and change. X equals. It doesn't look like anything simplifies. 3 times 25, which is what? 75. 2 times 28, is that 56? And that's your simplified fractions. If they want it as a mixed number, you go 75 divided by 56. 1. 1 times that, that's 56. 6 from 15 is 9. 5 from 6 is 1. 1, 19 over what? 56. So either answer. Okay. Big deal. What do we use the stuff? Let's take an example, or a few examples on where we use them. I have no idea what the tuition here, but let's say the tuition here is, you take in 6 credits, and your tuition for 6 credits, actually I can research that quickly. Cost. Where is the cost of college costs? Here we go. Tuition fees. Fall 2016. 6 credits. $1,212. $1,212. If the rate is the same, regardless how many is based on credit, how much would it cost you to take 18 credit? Well, let's say 16 credits. This semester you are taking 6 credits and you paid 1,212. And you are planning, you want to plan for next semester. You go, you know what? I got 16 credits to graduate next semester. Maybe I'll take them all in one semester and get out of here. How much would it cost you for the 16 credits? Cross multiply. X times 6 is what? 6x equals 1212 times 16 is 19,392. So to solve for x, we're going to do what? Divide by 6. $3,232. Another place where you can use this. You decide to take a trip from New York City all the way. You're going to drive to Orlando, Florida. So the distance from New York City to Orlando, Florida, roughly, is 1,100 miles. So this is New York City. This is Orlando. You drove for 4 hours and you are in Washington, D.C. It took you that distance from New York City to Washington, D.C., let's say 270 miles. And it took you 4 hours. Traffic wasn't really moving well. Not the way you would hope. Actually, that's not bad still. Maybe nobody was on the road. So if you maintain that pace, how long would it take you to finish the trip to go all the way to Orlando? We can set a proportion. It doesn't matter which one you put on the top. You can put the miles on the top or the hours on the top. Your answer is not going to change. So which way you want it? You want miles on the top or hours? Miles? Okay. So miles on the top, hours on the bottom. The Washington trip, how many miles?
1,100.
To Washington is 270 miles. And how many hours? 4. You try and figure out how many more hours you have to drive. How many more hours? That means what's the time to go from Washington to Orlando? The time is unknown. But do we know the distance from Washington to Orlando? Which is what?
1,100.
Not 1,100. 1,100 was from New York to Orlando. So what's the distance from Washington to Orlando? What is it? How'd you get 8:30, Jamie? How'd you get 9:30? Yes, you subtract them. 1,100 minus 270. That's where you have to travel. That's what's left. It was 8:30, Jamie. Yep. So you have 830 more miles to go. You cross multiply 470x equals, what is 830 times 4? 3320. You divide by 470. X equals what? You have 7, well, you're cruising there. 7.06 hours. So your trip all the way from New York to Orlando is going to be how many hours altogether? 11 hours. There's no way. There's no way you're going to get there in 11 hours. So you won't be going that fast, trust me. Yeah, you're not going to get probably from New York to Washington in 4 hours.
No.
Maybe if you take a high-speed train, because that's about almost 4 times 70 miles an hour you're going. You're not going through New York City at 70 miles per hour. George Washington Bridge and all that. Yeah, good luck. Oh, wait a minute. What is it? That's 270, not 470. What's 270 times x? Isn't that 270? I don't know where I got the 470. Isn't that 270? Nobody spotted that, huh? Divide by 270. I know it's 8 a.m. Too early? Divided by 270. That's better. 12.3 hours. $12.3 plus the 4, that's 17 hours from New York City. I done it from here to New York in 21 hours, and from here to New York is 3 hours, so it's not undoable. You could hit no traffic if you go late at night and nobody really on the road in New York City after midnight. You know, no construction, but the rest of the trip will take 12.3 hours. Another example. We'll take cooking. Try to mix some different ones. You're making a pie there, a small pie for, you have 8 of your friends, 8 people here. And you're going to make a pie. And the recipe calls, I don't know, this pie, you're going to put some sugar, requires 2/3 of a cup of sugar. And everyone loved the cake. Now somehow you get sucked into making this giant cake for your friend's wedding. And your friend is going to say, how many people coming? It's not many, it's only 128 people. So how many cups of sugar are we going to need? How many? So you can set a proportion. 2/3 of a cup for how many people? 8. For 128 people, how many cups of sugar are you going to need? Cross multiply. 8x equals, let's multiply that, 2/3 times 128. That's 128 over 1. 256 over 3. To solve for x, what are we going to do? Divide, right? 256 over 3 divided by 8. Well, 256 over 3, it reads divided by 8. When you divide by 8, keep, change, and flip, KFC. So what's 256 divided by 8? You can simplify that. By 8, this is 1. By 8, this is 32. It's 32 over 3. So let's go to the side. What's 32 divided by 3 there? 1. 1 times 3 is 3. Bring the 2 down. 2 divided by 3 is 0. So it's 10 and 2/3 cups of sugar. That's what you're going to need for that cake. 10 and 2/3 cups. Yep. Well, you got to feed 128 people. You can use it for cooking beside cake. Soon enough, Thanksgiving's coming. You're going to make a big turkey. Now, let's say you cooked a small chicken or turkey. It's at the same time, chicken or turkey. You cooked a 6-pound, and it took 2 hours this week. A chicken there, 6-pound chicken. The direction says 2 hours. Now, you go and buy a 22-pound turkey. How long is it going to take to cook it? Same thing. You can set up ratios. 6 pounds, how many hours? 2. 22 pounds, how many hours? Unknown. 6x equals what? 44. To solve for x, we divide by 6.
4.5 hours.
More than 4.5.
8.5 hours.
Let's see. 22 over, if you simplify that, that's 22 over what? 3? If you divide 22 by 3, 7. 7 times 3 is what? 21, and what's the remainder? 1. So 7 and 1/3 of an hour. What is a 1/3 of an hour? Isn't that 7 hours and what? How many minutes? 20? The hour has 60 minutes. A third of that is 20 minutes. So 7 hours and 20 minutes. So now you know what time to get up in the morning, put it in the oven. One common place we use that a lot is wildlife estimation. Wildlife estimations. What does that mean? We need to know how many bald eagles in Alaska. So we get all these eagles. That's an eagle here. There's my art. And we want to count how many bald eagles we have in Alaska. So the total number is unknown. We're trying to find out. So we set up some trap for them, and we go and we catch, and whatever we catch that day, we're going to tag and release. So tagged, or tag. How many get tagged that day? Let's say on the first day we tagged 12 of them. We wait for about a month, and we go back to the same spot where we went tagging there. Now on the second visit, the total number we caught is 16. And out of these 16s, how many were tagged? Let's say there were 4 of them. So we can set a proportion now. We can say x divided by 12 as the total over the tagged equals the total, which is 16, over the tagged, which is 4. Cross multiply, that's 4x. 16 times 12 192. To solve for x, we divide by 4. There are 48 bald eagles in Alaska. That's how we do wildlife estimations. That's how the government does them. Fish, coyotes, whatever. Tag them and release them. The first day they told, what is it?
How much they have, like, here,
How long do they have to do that
how
before
they
estimating?
produce.
Well, we figure with the number within a month. It's not going to be that much of a change within a month. Now, unless we had, let's say, for example, we're in Alaska and suddenly we have a massive fire, or you're doing a fish and there is a tanker just leaked 10 million gallons of fuel into the ocean. That changes the outcome. But if really no major changes happen there, that number should be very accurate, or close enough, because we do an estimation. You know, it might be 3-4 new eagles there, or maybe a few more or less because somebody hunted them, which is illegal. But you know, but that number is not going to change by much. My last example, I did this one time actually. I was doing a grant for high school one time in the summer, and I took the kids and I said, "Come on, we're going to go for a walk." The first day we met, trying to show them how math is actually helpful. You notice on the green we have these massive trees outside. And I'll set up this scenario for you. The class met actually at 3 o'clock in the afternoon. It was absolutely gorgeous, sunny out there. There's the sun. And I said, I need to find out. I took the group and broke them into groups of twos. So there are 2 people for each group. And I gave each one a yardstick. I said, I want you to tell me how tall that tree is without climbing it. So what's the height of that tree without climbing it? Because you know these trees are massive and I don't want anyone falling and breaking their neck. And that was it. That was what I set up for them. Sunny out there. Let's go outside for a walk and let's see how tall the tree is. And each 2 people got a tree. We have about 10 trees out there. We have about 20 people. A yardstick. So how would you do it if that was you?
Try to measure half and then. I don't know.
You gotta get an estimation, I guess.
Okay, how do you do the estimation, Jamie?
You gotta
No climbing trees.
measure half.
How do you measure half? The trees are massive. Half is like, for these trees, probably 20 feet high.
Shadow, I guess. I don't know.
Shadow? Okay, there's a shadow. I'll give you a story. There's your shadow. So what do you want to do with the shadow? Measure the length of it? I'll measure that for you. 12 feet. How is that going to tell me how high the tree is?
It can, but the sun sometimes when it hits it, it stretches the shadow out.
Well, it's true. Depends what time. Absolutely true. And why would it stretch it if you wait till 4 o'clock? Because the sun moved.
Yeah, it moves around. So
Sure. Yep, I agree with that. But how is the height going to tell him? Actually, the shadow is going to come in handy here. How about right after you measure the shadow, immediately you go, Jamie, you stand here. How tall are you, Jamie? I'm 6 feet tall. Okay, stand there. There's Jamie. There's a hat on his head. Let's measure your shadow, Jamie. And your shadow happens to be 2 feet. Can I set up a ratio now? Height to shadow. As long as you do them within minutes from each other, the sun didn't move that far. You can't do one at 2 o'clock and the other one at 5 o'clock. It's too late. But if you do them quickly, within like a few minutes from each other, the ratio of height to shadow, if I use height to shadow, 6 feet to 2 feet, that's your shadow, should be the same as the height of the tree to its shadow, which is 12.
That goes back to like where the military uses like a picture they would catch you where you at and what location in the world by like using the sun. I don't know how they do it, but they know where you at.
Now with GPSs now?
I don't know.
They've always
I think it's because they know it sets the shadow and what the sun is located.
So 6 times 12 is 72 equals 2H. Divide by 2. How tall the tree? 36 feet tall. I didn't have to climb it. Nothing. I can measure the shadow. It's not that difficult. Start from the tree and take the yardstick and start flipping it. And see how many times you got to flip it. Take your height and do a ratio. So there's a lot of ways you can do applications of proportions there. I'm just showing you a few of them. And I'll stop here